And what else? Well, did you know, for example, that Mercury consists of approximately 70% metallic and 30% silicate materials? So it's actually more metallic than rocky. Because of this, Mercury's density is the second highest in the solar system at 5.427 grams per centimeter cubed, only slightly less than the planet with the greatest density, that of Earth, at 5.515 grams per centimeter cubed. If Mercury happened to be the same size as Earth, that would mean it would pretty much have the same gravitational pull at its surface. But being the size that it is, its surface gravity is only 3.7 meters per second squared. If you were to compare its gravity to Earth, it would look something like this. This means the surface gravity of Mercury is only slightly less than what it is on Mars, and considering that Mars is a much bigger planet, that just says something about the density of Mercury. But before we leave the subject of Mercury's size, I want to show you one last comparison, that of Ganymede and Titan against Mercury. Now, Ganymede is the solar system's biggest moon and also the biggest moon of Jupiter, while Titan is Saturn's biggest moon and the second biggest moon in the solar system. These two giant moons are bigger than Mercury, as you can see here, but their masses are far less. If you look closely at Mercury's surface, you'll see its appearance is similar to that of our moon. It shows extensive mare-like plains and heavy cratering, indicating that it has been geologically inactive for billions of years. But it obviously was geologically active at one point, because one of the distinctive features of Mercury's surface is the presence of many narrow ridges extending up to several hundred kilometers in length. It's believed that these were formed as Mercury's core and mantle cooled and contracted over time when the crust had already solidified. And one of the most distinctive things you'll notice about Mercury is this huge crater on its surface called Caloris Basin, with a diameter of 1,550 kilometers. The impact that created Caloris Basin was so powerful, it caused lava eruptions and left a concentric ring over 2 kilometers tall surrounding the impact crater. At the antipode of Caloris Basin is a large region of unusually hilly terrain known as the Weird Terrain. If you compare this region to the rest of Mercury, you can see why it would have this name. So, what's it like on the surface of Mercury? Well, to start with, the surface temperature is hugely different all over. It can range from minus 173 degrees Celsius to over 400 degrees Celsius. It never rises above minus 93 degrees at the poles though, because there's no atmosphere retaining the heat. This means that there's quite a big difference between the equator and the poles, but this variation is also due to its orbit and rotation, which we will get back to later. The subsolar point reaches about 400 degrees, while on the dark side of the planet the temperatures are, on average, minus 163 degrees Celsius. Because Mercury is too small and hot for its gravity to retain any significant atmosphere over long periods of time, it's not able to retain any of the heat it gets from being so close to the Sun, which is why the dark side of the planet is so much colder than the side facing the Sun. Mercury, however, does have an exosphere, which is like an extremely thin atmospheric-like volume surrounding the planet. Molecules in an exosphere are gravitationally bound to a planet, but the density is so low that it can't behave like a gas because the molecules don't collide with each other. In this picture, you can see the MESSENGER probe's view of Mercury's exosphere. When solar wind hits the planet, it rips off certain atoms out of the exosphere, and what's left is this trail of atoms going into space. We call this the planet's tail, and every planet has this to a certain extent. Earth even does have an exosphere, but it starts at 600 kilometers above the surface. It's really the point where space and the atmosphere meet. Now, in the case of Mercury, this exosphere is not at all stable. Atoms are continuously lost and replenished from a variety of sources. NASA has been able to confirm that craters at the North Pole of Mercury contain water ice. Mercury also has something which Mars lacks.
One of the great challenges in this world is knowing enough about a subject to think you're right, but not enough about the subject.
Lacks an actual magnetosphere, or a magnetic field all around the planet. It is only about 1.1% as strong as Earth's, but it's still strong enough to deflect a lot of the solar wind around the planet. Now we're going to get to one of the things I find the most interesting about Mercury, its orbit and its rotation. Mercury has the most eccentric orbit of all the planets, with a distance from the Sun ranging from 46 million kilometers to 70 million kilometers. Now, this is something a bit hard to imagine, but bear with me. Mercury takes about 88 Earth days to complete an orbit around the Sun. It also has a 3-2 spin-orbit resonance of the planet's rotation around its axis. This means it spins 3 times around its axis for every 2 times that it orbits around the Sun. So although it takes about 59 Earth days for Mercury to rotate on its axis once, which is what we call a sidereal day, this 3-2 orbital resonance means that if you were actually standing on Mercury, it would appear that one day, from sunrise to sunrise, or what is called a solar day, is 2 Mercurian years. Standing on Mercury, that would look something like this. You would see the Sun rise relatively fast, and then as it approaches midday, it slows down and even starts going backwards before continuing on again to sunset. As you can see, that took a whole year, which means a nighttime on Mercury also takes a year. The Sun starts going backwards in the sky because approximately 4 Earth days before perihelion, the speed in which Mercury travels along its orbit equals the speed in which it's rotating. At this point, the Sun's apparent motion stays stationary. At perihelion itself, Mercury's orbital speed exceeds its rotational speed. So to a person actually standing on Mercury, the Sun appears to move backwards. 4 days after perihelion, the Sun's normal motion resumes. You can see this even clearer from a top-down perspective of Mercury. Twice a day on one of its poles, the Sun seems to pause and then continue on again. Something else to notice about Mercury's orbit is that it's inclined by 7 degrees to the plane of Earth's orbit. As a result of this, we can only see Mercury transit in front of the Sun when it's directly between us on Earth and the Sun itself. And because its orbit is inclined by 7 degrees, this only happens about once